Good morning, friends. In my last video, I explained you some chemical properties of the alkynes, and I also explained you the acidic character of the alkyne and some addition reactions. Today, I will give you some more addition reactions in chemical properties of the alkynes. See, first is addition of the hypohalous acids. That is, it may be HOCl or HOBr. Now this reaction takes place in the presence of the water. Ethyne reacts with HOCl in presence of the water. First one molecule of the HOCl added by removing the one pi bond. Then the second molecule added by removing the other pi bond, and it forms an unstable compound. And here it follows the Marcus law. Now this unstable compound, by removing the one molecule of the water, it formed the enol, that is 2,2-dichloroethanol. So acetylene or the ethyne, by the reaction of the hypohalous acid, it forms a aldehyde, that is 2,2-dichloroethanol. Now we take the example of the propyne. Again, one molecule of the HOCl added by removing one pi bond, and then by taking the second molecule of the HOCl, it formed the unstable compound. Here again, addition of the HOCl takes place by the Marconi law, and one molecule of water is removed, and here it formed the dichloroacetone. The point is that addition of the hypohalous acids gives the aldehyde of the ketone, that is the carbonyl compounds. These carbonyl compounds, they are formed by the action of the ions in the presence of the water with hypohalous acids. Now very important is the addition of the water. You see, addition of the water, you know, alkanes and the alkynes, they are immiscible in water. So as such, they does not react with water. But ethynes, in the presence of the sulfuric acid and the mercury sulfate as a catalyst, at about 330 K temperature, it reacts with water. Now, by removing one pi bond, HOH added, and in first stage it formed the vinyl alcohol, which is unstable. Listen, addition of the water. You know, alkenes and the alkynes, they are immiscible in water, but ethynes, in the presence of the sulfuric acid and mercury sulfate as a catalyst, at about 330 K, addition of the water molecule takes place, and in first stage it forms the vinyl alcohol. Now CH2 double bond CHO, H, that is vinyl alcohol, which isomerized to form the ethanol. Which isomerized, that is CH2 double bond CHOH, it isomerized to form the ethanol. So addition of water and ethyne, it formed the ethanol. Now, if we take a second example of the propyne, this propyne, in the presence of sulfuric acid, mercury sulfate, at about 330 K, first molecule of the water is added, and a unstable compound is formed. Then again isomerized to form the propanol. So here one molecule of water first added, forming the Marconi and then it rearranged to form the ketone, that is the propanol. Now the next is addition of alcohols and the carbonic acid. You see, in the case of the alcohols and the acetic acids, they break to form the acetines and the hydronides. In the same case, CH3O and the HIs. So, first alkyne reacts with alcohol in the presence of the KOH at about 400 K. Say, one bond breaks and addition of the H and OH-CH3 takes place. It forms the methyl vinyl ether. It forms the methyl vinyl ether. Now we take the reaction of the acetic acid. It also breaks like this, that is acetata and the hydronides. Now this ethyne reacts with acetic acid in the presence of the Lewis acid and mercury as a catalyst at about 350 K. Here two molecules of the acetic acid, they join one by one. So in first step, it formed the vinyl acetate, that is HCH2CH OOCH3, that is vinyl acetate, and again one more molecule of the acetic acid acts, it formed the vinylidene diacetate. So this is the addition reaction of the hydrolase acid and the addition of the water and the addition of alcohols and the carbonic acid. Now in my next video I will explain you oxidation properties of the alkyls, which are more important. Now if you like my videos, please share and subscribe. Thanks very much.